Very good morning to everyone. I'm going to discuss about an advanced energy conversion devices called fuel cell. Fuel cells are advanced energy conversion devices which in turn produces electricity through a clean electrochemical reaction with the help of hydrogen and oxygen. We know very well about energy harvesting devices such as lithium ion battery, potassium ion battery, supercapacitors, etc. But fuel cells are energy conversion devices with the help of hydrogen and oxygen. So, anode, cathode, electrolyte, catalyst, fuels, these are all typically we had already seen in traditional uh, energy harvesting devices. Here, anode, it's made from porous carbon, etc., which oxidize the fuel, facilitating the release of electrons. Similarly, cathode enables oxidant reduction reaction, and electrolyte allows a proton transfer between the between the electrodes, anode and cathode. Catalyst here typically platinum speeds up the oxidation and reduction reactions, and fuel here is very important to know that hydrogen. Oxidant is here oxygen, which facilitates reduction reaction at the cathode side. How fuel cell works? So hydrogen splits into protons and electrons. So those electrons will flow through the or travel through the external circuit, which in turn produces electric current. Those electric current would be used as a will be used as a powering the devices such as fuel cell vehicles. Protons move through the electrolyte to the cathode. Finally, at the cathode side, protons, electrons, and oxygen combine to form water. The only emission is hydrogen fuel cells. So types: proton exchange membrane fuel cells will operate up to 80 degrees centigrade. The electrolyte solution would be acidic polymer membrane as the electrolyte solution. For alkaline fuel cell, potassium hydroxide is used as electrolyte, which operates from 60 to 100 degrees centigrade. Phosphoric acid fuel cells will operate up to 150 to 200 degree in the range degree centigrade, which uses liquid phosphoric acid at electrolyte solution. Molten carbonate fuel cell will operate at high temperature 650 degrees centigrade. Molten mixture of alkali metal carbonates is the electrolytes. Finally, solid oxide fuel cell, which operates at very high temperature up to 1000 degrees centigrade. Yttria stabilized zirconia is the electrolytes used for SOFC. What are the advantages and disadvantages? It's a renewable and easily accessible one, and it is also less pollution compared to traditional battery devices. It is more durable, and it is also very good energy efficient. So fuel cells are well competitive with other energy harvesting devices in the market due to its versatile properties, especially minimum pollution, and charging time compared to other devices is less. We already discussed minimum carbon residues, that's why I told it's less pollution. So obviously some demerits would be there. Hydrogen removal will be the very tough one. So researchers are very facing the challenging in that. Transporting and storing hydrogen is also very difficult. Even though fuel cells are having advantages, these are all some of the disadvantages for fuel cells. Obviously we know very well it's flammable gas. That's also one of the major challenge. Need to be care sorry need to be you know uh, you know need to be taking care for protecting those. And obviously it is very high cost. Research on fuel cells is need more investment in the market. So these are all some of the disadvantages of fuel cells. So where fuel cells, we got some energy conversion, and where it can be applicable, of course, in electronics medium, and in especially in marine technology, and in power plant. Researchers are going very in depth how hydrogen can be used as a uh, regular energy sources for the public domain, which and especially for heavy vehicles with minimum pollution. That's researchers are focusing in depth to analyze those things, and also it is also useful in automobiles. So these are all the applications of fuel cells. So thanks and regards for watching the lecture.